Any formulas for area that we can think of? Any shape. What is your favorite shape when it comes to area? How do we work out the area of that shape? The easiest one is rectangles. How do we work out the area of a rectangle? Okay, we've got circles as well. So if we work out the area of a circle, it is pi r squared. Remember, we always have pi when circles are involved. Even when we're working out the perimeter or the circumference of a circle, we've got pi. And pi, we always use the value 3,142. Good. We've got rectangles or squares with the same formula. Length times breadth or length times width, whichever one you like to use. And what about a triangle? Does anyone remember? The formula to work out the area of a triangle? Okay, so yeah, you forgot the base part. Nice, Ashley. I can see half base times height. Good. Half base times perpendicular height. Awesome. Okay, so it's not imperative or important that you know these off by heart, but it does help. I don't think necessarily they would give you the formula for area of a rectangle, but for the most part, formulas are given. Okay, so just, yeah, this is important stuff to remember, especially units. Make sure your units are squared if it's area. If it's volume that we're looking at, your units are cubed. Sometimes you do get asked a definition. So I have seen it before in a past paper. They have asked for you to define perimeter, for example, or circumference I've seen as well. So please make sure that you do know these for the off chance that you do get a definition question. Okay, so let's put this into practice. I've again collected a few past paper questions so you can see how these types of things will be asked in a test. So the first question says, magic cubes were popular 3D puzzle toys in the 1980s. Study the two magic cubes below and answer the questions that follow. Okay, so as you can see, we have a cylindrical magic cube and we have a cubic, so square cube. They've given us the dimensions underneath. Okay, so we just take a moment to see what we've been given. All right, first question. Calculate the radius of the cylindrical magic cube. Calculate the radius. How are we going to do that? Any takers? Diameter divided by 2. Perfect. So let's just remind ourselves. With a circle, distance from one edge of the circle to the other edge of the circle is our diameter. Our radius is halfway to the edge of the circle. So our radius is half our diameter. As you can see in the diagram, they have given us the diameter. So radius is equal to diameter divided by 2, which is 67 divided by 2. And let's see, we've got an answer in the chat. Perfect. Don't forget the units. 33,5 millimeters. Okay. Question 2. Calculate the total volume of the cylindrical magic cube in millimeters cubed. Okay, so the question's asking us to calculate the volume of the cylindrical magic cube, and they want the answer in millimeters cubed. They have given you the formula. They say the following formula may be used: pi times r times height, where pi is equal to 3,142. Now, it's important to note that this is not the usual formula you are used to. You're used to seeing pi r squared times by height. It is the same thing. Instead of writing radius squared, they just said radius times radius in the formula, which is the same as radius squared. So if you are given a formula in the exam and it looks slightly different, just trust the examiner. They're not going to give you the wrong formula. It's maybe just another way to work it out or another way to set up the formula. Okay, so using that formula, I'm going to give you guys a few minutes to quickly work out the volume. When you have your answer, you can share it in the chat, or tell you I'm just double checking. I got a different answer. Yes, Coquette. So that's the answer that I got. Or tell you just quickly check that you've included all the dimensions. Amor, yes, correct. Nomusa, yes. Okay, I see the right answers flying in now. Okay, so just quickly, nice and easy. The formula has been given to us, so it's not too difficult. We substitute pi into the formula. The radius we've just calculated is 33,5 times by 33,5, and the height of the cylinder is 60. Everything's in millimeters, so that's all you have to do. Just substitute into the formula that was given, and you get 211,566,57 millimeters cubed, because it is volume. And they also did remind us in the question to put our answer in millimeters cubed. Okay, awesome. Okay, so don't be overwhelmed or think that you are doing the wrong thing. With volume and surface area, you will get big numbers as your answer. Okay. Let's have a look at the next question. Calculate the total surface area of the magic cube in millimeters squared. The following formula may be used. Total surface area is side times the number of sides. Okay, so in this instance, you're looking at the magic cube, which is this shape. You're working out the total surface area, its area. So our answer is going to be squared. And they've given you a formula. I'm going to give you guys some time to quickly try and figure out that formula. When you have your answer, you can share it in the chat. Yes. Musa, yes. 19,494. Perfect. Okay, so let's have a look. The formula, again, slightly different formula to the one we are used to. They said side times side. So we take the side, which is 57 times 57, because it is a cube, and we times by the number of sides, and a cube has 6 sides. Okay, and then that gives you an answer of 19,494 millimeters squared. Amos, raise the hand. Let's
Ma'am, I wanted to ask if it's always 6 sides, because here I saw 3 sides on the diagram.
Okay, yeah, so it is always 6 sides. So it's not always possible to show the 6 sides on a piece of paper. So we've got to just know that there are 6 sides when it comes to a cube or a rectangular prism.
Oh, okay. Thanks, ma'am.
Okay, pleasure. So that is a very good question. Like in the picture, you only see 3 sides, but you've got to imagine that there is a side at the bottom. There's another side at the top. Sorry, on other side on the left-hand side, and we have a side at the back of this shape. Okay, so there are 6 sides to a cube or rectangular prism. All right, so all in all, guys, I know in general, when you see shapes like this, it can be overwhelming, but at the end of the day, was that a difficult question? If this was in your exam at the end of the year, how would you feel? Happy, thumbs up. Okay, great. It's very possible. This is from a past paper. So let's hope we get something like this. And as you can see, formulas were given. Okay, so you don't need to stress too much about that. And if they look different, just trust the examiner. Okay, they're not going to give you the wrong formula. Okay, so let's have a look at a slightly different shape. This one we haven't really looked at a lot. It's not that common. So we're looking at a triangular prism. So a real life example would be the Toblerone chocolate. Okay, the first question says, calculate the total area of all the rectangular sides of the chocolate pack. Okay, so let's just look at that again. The total area of the rectangular sides. Then it says you may use the following formula, length times width. So I want you to look at the shape and see where you see rectangles. You're going to work out the area of all the rectangles and get the total area. I'm going to give you guys a minute or two to try to figure this one out. Let me know if you're struggling or if you have a question. So I'm going to try my best to give you a clue. With my colors. Oratile, well done. Okay, well done. I'm seeing some correct answers here. Okay, anyone else? Okay, so the first thing is to realize that there are 3 rectangles on either side of this triangular prism. So we've got 2 triangles on either end, but then there are 3 rectangles that make up the sides of this shape. Now, if we have a look at the pink rectangle that I outlined, that has a length of 8 centimeters. Okay, and a width of 4.2 centimeters. That gives you an area of 33.6 centimeters squared. So now I saw quite a few of you with that answer, which is correct, but we're not finished just yet. That is the area of the bottom part only, the bottom rectangle only. Okay, we still have rectangle on the one side, rectangle on the other side. So the blue rectangles actually have a length of 8. So the length is still 8 centimeters, but the width is 3 centimeters. So if we have a look here, 3 on the side, but it's 8 length, 3 this side, 8 on that length. And that gives us this rectangle on the one side. Okay, but now this rectangle is going to match the other one on the other side because we've got 3 centimeters over here, and then imagine 8 across. So there's our other rectangle. It's just really hard to see it, but we can see we've got 3 centimeters and the length across the whole thing is 8. So there are 2 rectangles that are the same. So I'm going to just times by 2. Okay, so that gives me 24 originally, times by 2, which is 48. So therefore, to get my total, 33.6 plus 48. Nice. Okay, so and Ben, well done. Okay, so that one was a little bit tricky because not all the rectangles were the same size. The bottom part of the triangular prism, should I say, was a little bit wider than the other 2 sides. It's also quite a different question. Normally they ask for the area of the whole shape, not just the 3 rectangles. Okay. Next question. Calculate the perimeter of one triangle in millimeters. Calculate the perimeter of one triangle in millimeters. I'm going to go back up. Let me give you guys some time to figure that out. The perimeter of one triangle So perimeter is our outline or distance around a shape. We're looking at triangles, the distance around the triangle in millimeters. So we have to do a conversion. Nice, Ashley, good. Okay, so now I can see the answers coming in. Okay, so perimeter is the outline or the distance around our shape. So if we're looking at triangles specifically, and they said one triangle, it's just the distance around this triangle. Okay, so to work that out, we just go and add all the sides together. So we have 3 centimeters on the one side, another 3 centimeters on the other side, and the bottom of that triangle is 4,2 centimeters. Okay, that gives you an answer of 10,2 centimeters. However, they wanted the answer in millimeters. So we have to times by 10. Remember, we need to know these conversions off by heart. And that gives us 102 millimeters. And because it's perimeter, we don't need to square the unit. Okay, it's not going too badly. Well done, guys. All right, let's try another question. So this question comes from the Western Cape prelim of last year, paper 2. Slightly different shape, but we can see it makes up 2 shapes that we are familiar with. Got a rectangle and 2 semicircles. So let's have a look. It says the athletics track below is made up of a rectangle in the middle and 2 semicircles with a radius of 36,5 meters at the ends. The length of the rectangle is 84,39 meters. Okay, so they've given us all the measurements in the question as well as on the diagram. Okay, so let's look at question 1. Calculate the perimeter in meters of the rectangular area in the middle of the athletic track. You may use the formula perimeter is equal to 2 times length plus width. Okay, so just take a moment to have a look at this shape. They've asked for you to work out the perimeter of the rectangular bit of the track. I'm going to give you guys a few minutes. If you need some help, let me know. Namusa, are you working out area perhaps? I think that is the area of that shape. Yeah, you worked out the area. Okay, guys, if you have your answers, let's see them. So in order to work out the perimeter, we need to know the distance or the value of each side. We know the length. Oh, Koketso, do you want to let us know how you did that? You got it absolutely right. Is there any chance you willing to tell us over the mic how you did that?
Talk to us and tell us how you got that fantastic answer.
It's a very small group tonight, so don't be shy. Okay. That's fine. But well done. That's amazing. Great answer. Okay, so like I was saying, we need to know the value of all the sides. We know that the length is equal to 84,39. Sorry. But the width, we're not really sure of, but they did tell us that the radius is 36,5. But now remember, the radius is any length from the center of the circle to the edge of the circle. So that's also a radius from this midpoint. So this part is also 36,5. And this part is also 36,5. And likewise with the side over here, that's the radius and that's the radius. So in actual fact, we're looking at the diameter of our half circles on the sides here. So to get our width, first need to work that out because it wasn't given to us. It's 36,5 times by 2, or you could say 36,5 plus 36,5, which gives you 73 meters. Now that you know the width, you can use the formula, or you could just add all the sides together. 2 times the length is 84,39 plus the width, which is 73. And that gives you 314,78 meters. Remember, always 2 decimal places. So just quickly how that would be marked, that was for 3 marks. They would give you a mark for figuring out what the width is, substituting into the formula, and your final answer. Okay. The next question, calculate the total area of the inside of the track in centimeters squared. Calculate the total area of the inside of the track in centimeters squared. And they've given you some formulas. Formula of a circle, area of a circle, and area of a rectangle. So total area that means we are going to be working out this whole shape over here, the area of this whole shape. Do you know how we can do this? Does anyone have an idea? So because it's not a regular shape that we are used to, we're going to divide it into the shapes that we do know. So we have our rectangle. So we can work out the area of the rectangle, and we have all the sides necessary. So you work out the area of the rectangle, which is the second formula there. And then we have 2 half circles. But remember, 2 half circles make 1 full circle. And we've been given the formula to work out the area of a circle. So you're going to work out the area of the rectangle, work out the area of your circle, and we can then determine the total area of the inside of the track. Let me know if that doesn't make sense. If you guys are fine, I'll give you a couple of minutes to quickly calculate that area for me. Machle, no worries. I understand there's always issues with network. You're not the only one. We have done, I think, 2 past paper questions already, but you are able to check them on the website. I'll check the recording, I think, by tomorrow. Check it on YouTube or the website so you can catch those up. Yep, that is the area. That is correct, but it asks for centimeters squared, so we have to do a conversion. Don't worry, believe it or not, I also forgot about that conversion the first time I looked at it, so it happens. Okay, we've got some big numbers here, yeah. Okay, so let's have a look at this. Is there anyone willing to tell me, speak up a little bit and tell us how they got the area of the rectangular part? A nice and easy one. Anyone? Okay. So, guys, my advice is when it comes to a question like this and you have to work out the area and they've asked for the area to be put into another unit, do your conversions before you start times and everything. Because once you've got your area in meters squared, to get it to centimeters squared is not just times by 100 anymore. It's times by 100 squared, which most people do forget about. So I'm going to show you how this works. So let's have a look at area of the rectangle. So it's our length times width. Times by. Okay, so let's convert that to centimeters. So we're going to times by 100, times by 100, which gives us which gives quite a big number. Okay, that's area of the rectangle. Then area of our circle is pi times radius, or you can say radius squared. Our radius is 36.5 meters squared. So I'm just going to quickly convert that to centimeters. So we times by 100. It's still squared. So okay, so our total, we would have to add these numbers together. And we get this massive number as our answer. Okay, which I can see most of us have gotten. Do I have any questions with this one? Okay, so this question became a bit more intense because of the conversion to centimeters squared. So my advice is always convert before you start doing your calculations. Because a lot of you will see now, once you got your answer in meters squared, when you did the conversion, you didn't get it right. So when you get your answer in centimeters squared, so if you're going from, meters squared to centimeters squared, normally meters to centimeters times by 100, but because these units are squared, your conversion is squared as well. Okay, same applies. If we're looking at millimeters to centimeters, normally we divide by 10, but as soon as we say millimeters squared to centimeters squared, our conversion is squared as well. Likewise with cubed, if it was millimeters cubed to centimeters cubed, you divide by 10 cubed. But again, we do normally forget these conversions, so I always just convert in the beginning, so it's the normal conversions, and then we just get our answer. Amor, let me check that for you. Okay, so we worked out the width over here. So our rectangle is the 83.39 plus our 36.5 plus 36.5, which is our 73. So that's how we work out the area of the rectangle, length times width. Okay, so it's what we worked out in the previous question. All right, let's move on to hopefully a better, not so hectic question. Let's look at question 4. So this comes from the Free State prelim of last year. The following is a picture of the Samsung S20 cell phone together with the dimensions of the cell phone. Okay. We've got our cell phone on the left-hand side. We've got our dimensions, the length, the width, the thickness, the weight of the phone. Question 1. Oh, lovely. Determine the weight or the mass of 7 of these cell phones in kilograms. So we need to work out the weight of 7 phones in kilograms. Okay, I'm just going to quickly move up for those that didn't manage to get a screenshot of the previous question in time. Hey, let's go back. How are we going to work out the weight of 7 cell phones? The last question, take it out of you guys. Yes, Cowboy and Ashley. I'm not sure what happened there. Slightly off. Okay, so we're looking at the weight of the cell phone. We want to know the weight of 7 cell phones. So we look at the weight of 1 cell phone, which is 163 grams. That's for 1 cell phone. So for 7, we times by 7, which gives us 1,141 grams. They want the answer in kilograms, so we need to remember our conversion. So we divide by 1,000, which gives us 1,141 kgs. And it's also okay if you round it to 2 decimal places, because that's what we normally do. So 1,14 kgs. Nice, nice. Okay, looks like we got that. Just remember to always show whatever you're doing with your conversion. If you're timesing by 100, dividing by 1,000, because you always get a conversion mark. Okay, which formula, so we're going to choose between A, B, C, D, can be used to calculate the perimeter of the Samsung cell phone? What formula can we use out of the 4 options to work out the perimeter of the Samsung, which is a rectangle? Is it A, B, C, D? Remember, perimeter, not area. Ooh, again, lots of different answers here. Okay, so let's just remind ourselves. Length times width would give us the area of a rectangle. This formula just gives us the area of 2 rectangles. C is the correct answer. That is the perimeter of a rectangle. And then D is actually to work out the volume of a rectangular prism. Okay, so well done to everyone that said C. C is the correct answer. So quite often people do get confused. We don't like to believe that they're actually going to ask us about perimeter in an exam because it's too easy. So whenever people see perimeter, they just assume area, which I see some of us did get confused with. Okay. Then let's try this next question, which is also part of measurement, looking at time specifically. Sandile leaves his home exactly at the time displayed on the cell phone and arrives 2 hours later at his destination. Determine what time he reaches his destination and write that time in words. So let's just quickly check the cell phone. There's a time provided to us. The time on the cell phone is 11:51. So I'm just going to write it down here so you can see the question. Time on the cell phone is 11:51. So Sandile leaves exactly at the time displayed on the cell phone and arrives 2 hours later at his destination. Determine what time he reaches his destination and write that time in words. Yes, Ashley. Okay, so first step is to actually work out the end time. So we add 2 hours. Okay, because remember we need to show working out. It's for 3 marks. So that means he gets there at 13:51. Okay, so that's already 2 out of the 3 marks. Showing your working out, adding the 2 hours, getting your final time, and then we need to write it in words. We don't say 13:51 or 50 or 1:51. Remember, we always have to say 9 minutes to 2 o'clock or 2. Normally, if they want the full time, you'd have to say 9 minutes to 2 in the afternoon. Yeah, but you didn't have to include in the afternoon in this particular question, but 9 minutes to 2 was your 3rd mark. Okay, so let's just quickly look. Let me rewrite this differently. Okay, sometimes it's not always easy to add the time. Okay, so we'll write 11:51 and we are adding 2 hours. Okay, and we just do normal addition. That is 1, that is 5. We say 1 plus 2 is 3. 1 plus 0 is 1. And that's how we get 13:51. We can't say 1:51 because that's not how we say analog time. So when we learn time in class, you would see that it's 9 minutes past 12 in the morning or 9 minutes past 12 in the afternoon. Or as soon as it goes past 1/2 we say 25 minutes to whatever. So as soon as it goes past 1/2, so 30 minutes, we start saying however many minutes are left to that hour. Pleasure, Amor. Okay, to finish off question 4, let's have a look at the 4th question of question 4. Determine the difference between the width and the thickness of the cell phone in millimeters. So difference is a keyword between the width and the thickness of the cell phone. So I'm going to go up quickly. The width and the thickness. So we're specifically looking at these two amounts. The difference between the width and the thickness in millimeters. Don't lie, Oratilia, the same question. Okay, I can see correct answers coming through. Difference means minus. So we take 69,1 minus the thickness. Nice, I see we all got that. Okay, well done, everyone.